In this video segment, we like to do example 1.1.2. Determine whether an element belongs to a given set. If we let set A denote a set which consists of all Asia countries, then China belongs to Asia countries, so is Pakistan. United States does not belong to, so you want to use this symbol. United States does not belong to Asia country, neither Australia. So Australia does not belong to Asia country. If you look at the map, you see here, Asia is right here, American is here, and Australia is here. So American, USA, and Australia does not belong to Asia, but China roughly here and Pakistan roughly here. You see the picture, China is here, Pakistan is here. All right, so that's the question 1. Question 2, if we let set B denote the solution set of x squared plus x minus 12 equals 0. Here x, again, the first x represent the element, and the second one is the condition, with the vertical line to separate the representative and the condition. Here we know -3 does not belong to the solution set. Why? Here is the detail. Let me put detail right here. You see, if you plug in -3, then squared, and then plus -3 plus 12, replace x with -3. Negative is positive 9. -3, -12 together is -15. So the answer is what? Is -6, which does not equal to 0. All right. So how about +3? +3, if you plug in, there is no problem. 3 squared plus 3 minus 12. Here you have a 3 squared, means 3 times 3, which is 9, plus 3 minus 12. You see those two together is 12. And then you can see then 12 minus 12 is 0. So indeed, 3 belongs to the solution set B, and -3 does not. So you may write here, -3 does not belong to the solution set. 3 indeed belongs to the solution set. Okay, so that's the second question. The third one, we want to use C represent an integer which is in between -5 and +5, including -5 and +5, because there is an equal sign right here. Okay, so we want to use the set notation. This is the set notation. So then we can see here, -2 will be in C, negative 2 will be in C, because if you withdraw here, this is the excess. Here you will have a negative 1, negative 2, negative 3, 4, 5, and then we can see here as negative 5, which is included 1, 2, 3, 4, 5. Is 5. 1, 2, 3, 4. Okay, and then we can see here negative 2 is between negative 5 and positive 5. So indeed, negative 2 belongs to this set, which is an integer. 3.3 is roughly here. 3.3. You may say is inside, but remember, 3.3 is not integer. Z stands for integer. Okay. See, this letter stands for integer. Okay, so in this case, 3.3 is a decimal number, so which does not belong to the integer. Even is greater than negative 5 and less than 5, but 3.3 again is not integer, because Z stands for integer. That's by mathematical convention. When people see Z, that's integers, including positive, negative integers, and also real. Okay, all right. I'll see you next time.